This week we are starting our study on the states of matter, and specifically we're going to focus on phase changes, changing between solid, liquid, and gas as we change temperature. And we're going to kind of define a few different variables that affect phase before we start doing our vocabulary boxes. So we have already talked about these terms before, but I just want to kind of bring them back to memory because they will be important throughout this unit. So we already said that these changes in state often occur as a result of temperature. And we have defined temperature as heat energy in the past. And another way that we're going to talk about that in this unit is kinetic energy and potential energy. So kinetic energy is the movement of particles. And as we have more kinetic energy, we have more heat. And that's what we define as hot or high temperatures, or lots of movement within our substance. And it kind of looks like that. Like when water is boiling, you can see the particles moving because you start to see bubbles. So as we start to move in the phases from solid to liquid to gas, we have higher temperatures and more movement between the particles. So I'm going to write kinetic here, which is movement. Okay. The other two variables that are going to be important in this unit are pressure and volume. So pressure, I don't think we have defined this, but pressure is force, like force on an area. And pressure also affects the state of matter. If you think about the particle arrangement of a solid, they are pushed together tightly, and you could say that solids exist pretty well under high pressure. They're not compressed and they're not able to expand. But generally, if your pressure is high, you are more likely to find your substance as a solid. Then we have kind of the less pressure gas, where their particles are free-flowing and able to expand and be compressed. So we have pressure, and while we're talking about these two variables, I also want to introduce some units. So pressure, when we talked about standard temperature and pressure in our last unit, we said that atmospheric pressure is 1 atmosphere. So there's 1 unit of pressure, atmospheres. But we also have some other units of pressure that you might see. So in different units, these are all equal to 1 atmosphere or atmospheric pressure. So there's also kilopascals. It's another unit of force. So 101 I think it's actually 101.5. You know what? Let me double check on that. While I'm checking, atmospheric pressure is also equal to 760 torr, is another unit of pressure or force. And okay, I figured it out. 101.3, I was right. Kilopascals. Sometimes you just question yourself. And another unit, there's one more that is the same as torr, it's just a different label, is millimeters of mercury. Way back in the day, they would measure pressure, kind of atmospheric pressure, by how many millimeters a sample of mercury would move within a tube, and that was the amount of force that the atmosphere was pushing down on it. But it's the same amount, atmospheric pressure, as torr. So those are some different units of pressure. And then also temperature, we've said standard temperature is 0 degrees Celsius. And the other unit that we will see is 273 Kelvin. So Kelvin is another unit of temperature, and Kelvin measures the movement of particles. So fast-moving particles are going to have higher Kelvin, and 0 Kelvin is absolute zero, meaning no movement of particles, which actually has not ever actually happened in lab conditions, because really by just observing it, we add energy to the system. So they've gotten close, but Kelvin is an absolute temperature scale, so there are no negative numbers. And to convert between the two, you would just add 273 to whatever your degrees Celsius are. So those are our two variables that will play the biggest part in this section. And then I also mentioned volume. We'll just go over this one quickly, is the space that matter takes up, and that's measured in liters. And we already looked at that relationship between pressure and temperature and volume a little bit in our previous unit when we talked about molar volume, because the space that a gas can take up has to do directly, is directly related to the temperature and inversely related to the pressure, which we will look at more in the coming weeks with gas laws. So now let's get into the meat of our unit vocabulary for the week, now that we've defined some variables. So first, matter is a review term. Matter is any substance that has mass and takes up space. And if it has mass, that means it is able to be measured in grams. And if it occupies space, it's able to be measured in milliliters or liters, has a volume and a mass. The three most common states of matter are solid, liquid, and gas. There is a fourth called plasma, which has to do with charged particles, but we are not going to be focusing on plasma because it does not transfer from one to another based on temperature and pressure changes. But these three states of matter do, and they depend on, just like I said, pressure and temperature changes within the substance. So let's take a look at our three different samples, solid, liquid, and gas, and how they can change between them. So a solid is a substance with tightly packed particles, and it has a fixed shape and a fixed volume. So think about any solid object, an ice cube, for example. If I put an ice cube in several different containers, it stays as a cube shape, and it still takes up the same amount of space. So it's not going to change based on the container. The two different phase changes that involve solid are freezing and deposition. The freezing occurs when liquid turns into a solid. And we know this well. You know, if it rains and then it freezes overnight, then now you have ice, right? So there's freezing, liquid to solid. And then deposition is actually gas to solid. Think about snowflakes, maybe changing from vapor straight into solid. There's deposition. A liquid is kind of our intermediate state of matter. It's free-flowing particles, but they're still packed together. They can flow easier than a solid. It has fixed volume, but changing shape, and we call that variable. So variable shape, if it can change. Fixed volume. So we think about a water sample. If you pour it into a cup versus into a vase, it will take the shape of its container. So that's what we mean by a variable shape. But if it's 100 milliliters, it will stay containing that same amount of space regardless of what container it's in, which is why it's a fixed volume. The two changes involving liquid are melting and condensation. So melting is kind of the opposite of freezing, solid to liquid. And condensation is when you have a gas that turns into a liquid. If you've ever had like water vapor in maybe the shower or even near your car, and then it condenses on the window back into a liquid if it gets cold, that is condensation. And the third phase that we're going to look at is gas, and this is the most free-flowing particles that can exist, and it has the particles are spread out pretty far from each other, and both shape and volume are variable. They can change. They will fill their container, and I've used this word compressible and expandable. Gases can expand to their container or be compressed into a container based on kind of the pressure, the force that's around it. The two phase changes that involve gases are vaporization. That's when a liquid turns into a gas, so like boiling or evaporation. Both of those are forms of vaporization. The difference being boiling requires temperature change and heat added. Evaporation is a natural process by which the atoms of a liquid turn into a gas through vapor pressure. But they are both considered vaporization. And then sublimation occurs when a solid turns straight into a gas. And an example of that is dry ice. We have solid dry ice, and it turns into kind of that characteristic fog that we think of when we think of dry ice. Gases are compressible. So they can change their volume. And then the last term we're going to look at is heat transfer. And heat transfer is the process by which phase changes occur at standard or at constant pressure. So if our pressure is not changing, phase changes are going to occur based on our temperature changes. So we have two different ways we can transfer heat. One is to add heat. And if we're adding heat, that means we're going to be speeding up the particles. More movement. Okay. And if we're adding heat, we call that an endothermic process. Endo is like in. And the other way we can change the state is by losing heat. So we have less movement. And if we're losing heat, this is exothermic. Sounds like exit. Heat is exiting. Those are our two types of processes, endothermic and exothermic. The three processes that are endothermic, that require heat to be added, are vaporization, sublimation, and melting. And the three that lose heat when they occur are freezing, deposition, and condensation. So now we have our little example here, and you are just going to label these boxes, solid, liquid, and gas. So let's go ahead and do that based on the particle arrangement. This one is the most packed, solid. This is the most free-flowing, there's gas, and this one is liquid. Then you are going to identify and label each phase change on the arrow. So that should be pretty straightforward using what we did up here. So we'll do one together and you can do the rest. Let's look at this bottom one, liquid to solid. So this arrow right here would be freezing. So label each arrow. And then lastly, color the arrows of the process that require heat. So that would be our endothermic processes, red, and the processes that lose heat, blue. So think about our particles, if they're getting more energy, so if they're becoming more like a gas, they are going to be red. If they're becoming more like a solid, they're going to be blue. So you go ahead and color those and we'll go over them together on Thursday in the Zoom.